Yes, good morning, Tala, Alfred, Christian, Lawrence, Musa, and I think 3 days ago I posted on your WhatsApp platform some demonstration on different actions happening on steel canopies, such as the afforestation and others. And we were looking at the different effects of actions like dead load, applied self-weight, live load, wind, temperature. I also made mention of two critical connections that normally the engineer need to pay attention to and put some emphasis. One is that this is B between this column and the support down. That is the base for the foundation with a linkage through base plate and anchor bolts. So at B here, when you look at this table up, this table is the different actions or reactions. This is the reaction values. So these reactions in the X direction, in the Y directions you have the Z that is vertically down, or if it is uplift it will definitely be facing up. You can see the nomenclature here. You have a bit of moment that need to be taken care of in your bolts and plate connections. And then yeah, basically this is a demonstration that if you do it manually, this is both ultimate and serviceability. So these are the characteristics, the frequent and then the quotient. So if you look at A is now reactions due to roof truss loads. If you detach this roof element from these columns, definitely you have reactions at this point. And these different reactions are actually presented here. So here you don't see anything with moment. There's no moment here. Moment values are not here. Unlike for the column base, you will see some moment here which need to be taken care of. So if you use your software, it should be able to input all this value, and you're able to get the realistic fits. For the roof truss system, it seems you only concentrate on reactions in the X, Y, and Z. And these are individual, self-weight, dead load, live load, wind in the X direction, wind in the Y direction, and wind in the Z direction, temperature. But temperature seems to cancel at the end of it when you are doing your reaction value. Temperature, you can see positive, negative value, these definitely cancel. But what I'm trying to emphasize here is the different loads that need to be taken care of. If you want to take your vertical load, you do tributary area and then you get a vertical load and X. Sometimes even the Y loading you may not be able to generate in some of these components here. So sometimes it is beneficial to use software to do some of this complicated analysis, so that you are able to get the exact loading, and then you use your code to practices to another literature and text to help you design. If you look at McGinley, I think structural steel designed by McGinley has very good bolted connection, base plate design, which I think will be able to guide you properly here. The fixity at the base plate area, I think for these sensitive canopies, it's also not bad if you encase you after bolting and doing all the connection to avoid the corrosion, durability challenges, you can encase it. Try to control water managers, water movement around here, get proper drainage to keep it dry all time so that the connections are not affected by corrosion. So for you to achieve full fixity, I think sometimes it's good to encase even this design connection properly so that the rigidity is 100%. in line with the actions from wind. Wind is the worst force here. If you do on the vertical loads and the live load, I think, and dead load, I think that would be okay. But once it's subjected to wind, then you get into problem. So basically this one, I just wanted to demonstrate to you based on the other demonstration of forces acting on the canopies, that also key to those forces, you need to mark out the critical area. Of course, some of these connections, if you realistically design based on architectural design, definitely you also design individual connection locally, and then the global are these two. Local to this, you have all these connections. Then when it is global behavior, you have, I think, 4 serious connections. These two down here, and then the A is up here. Basically, I think that should help you if you are not given some of these tasks. You should be able to definitely look into it carefully, systematically, and be able to question and put something which is good. I think this is exactly what I wanted to point. These reaction values are very necessary. The actual values will depend on what load you applied. These are site specific. A canopy in Gulu, a canopy in Barara, a canopy in Bale will have different wind loading, but dead load, live load could be similar, and temperature will be different. Temperature will be different, and wind. So that one you need to take note of. But so it's not just picking a design from Kampala and take it to Arua. From Arua, use the same design in Kisoro. Then you definitely get into trouble. Something, even the geotechnical capacity, information bearing capacity will be different. So you need to be careful on dealing with parameters regarding soils. Soils in the north, soils in northeast, soil in the west, here in central and south, they're completely different. And the depth to sound bearing strata also vary. So your foundation will be site that specific based on parameters you determine from there. Yeah, that is very good. And please, you make sure you consult during your design, the design process, the role play, make sure everybody is responsible for their area of jurisdiction. They should, like the geotechnical team, should give you the parameters for you to use. Is always very, of course, if you are in a hurry, you can make assumption, but then you have to validate when the study is done. That is something that you need to know. And architects will give you the architectural design based on the employer's, the client's dream, and then you will be required now to interrogate and try to put in the skeleton, the structural. Okay, that is good. I think this one should be good for you guys. Thank you so much. Please read about structural steel design. There are many literature, many texts, even internet information will be able to guide you and some of this similar stuff. I know at the university you guys, you have covered steel design, timber design, and reinforced concrete. So you go back and look at connection detail, the code of practices are there, literature are there, steel members in compression, tension, all that are there. Please try to read so that you don't get lost when you are faced with these challenges. Thank you.